The title of this research is Design Strategies for Visually Engaging Solar Skins Between Dynamic Displays and Energy Generation. This presentation is supported by the University of the West of England as part of the author's participation in the 16th International Conference on Design Principles and Practices. It is based on research conducted by the author as part of her PhD studies with the University of Brighton, sponsored by the University for the Creative Arts. The human experience of urban spaces is influenced by the physical characteristics of the settings. Architectural skins play an important role in people's perception of cities, while also impacting the energy performance of buildings. Within the context of the climate crisis, facades need designing to enhance people's experience of urban open spaces and reduce buildings' carbon emissions. Architectural envelopes, which can act as visual attractors, such as media facades serving as dynamic digital displays, can increase buildings' operational energy use. On the other hand, active solar technologies may be integrated into facades to supply buildings with renewable energy generated locally and meet zero-energy building standards. This invites consideration of how facade designs may be conceived to attract attention and interest, thus engaging people visually in public spaces, without needing operational energy and offer, instead, opportunities for energy generation. This research explores the design of architectural skins which can stimulate visual engagement passively by minimizing operational energy use and facilitating the building integration of active solar technologies. Through an interdisciplinary review of literature and design cases, this study considers architecture's communicative role, aspects of visual perception, and examples of architectural skins with the ability to attract attention. It examines advances in active solar technologies, discussing challenges and potential for integrating them into visually engaging building skins. The conclusions suggest design principles as passive strategies for embedding dynamic digital media and active solar technologies into facade designs. Buildings are responsible for more than a third of energy use and greenhouse gas emissions. Most of the energy used in buildings is still generated from fossil fuels, which needs changing rapidly. We urgently need to reduce buildings' carbon emissions by minimizing their energy use and supplying them with energy generated as much as possible from renewable sources. In other words, we need to transition to zero-energy buildings, or even active buildings that can generate more energy than they need, and share it with the local grid. Integrating solar technologies into the building envelope can facilitate the transition to zero-energy and active buildings. At the same time, architectural skins have an important communicative role and impact the human experience of urban spaces. Active solar facades generate electricity and heat from solar radiation, which is widely available. They can contribute significantly to supplying buildings with energy generated from renewable sources, thus helping us reduce the use of fossil fuels. Active solar facades can take various forms and use different solar technologies. Their role can be relevant despite their often unfavorable angles. Solar technologies are in continuous development, and photovoltaics in particular have become cheaper and more accessible. Solar facades can add to the energy generated by solar roofs, which can be critical to providing energy generated from renewables in densely built cities. Active solar facades can present different degrees of transparency or can be fully opaque. They can integrate photovoltaic-based technologies converting sunlight to electricity, solar thermal technologies for heating systems, and combinations of the two types. In renovations aimed at improving buildings' energy performance, solar facades can also contribute to enhancing the exterior architectural appearance. Architecture can be thought of as a form of communication. As they experience urban environments, people associate the physical characteristics of spaces with meanings, becoming fond of places. While the human experience of spaces is affected by all the senses, vision generally plays an important role in the perception of building facades, which are usually viewed from a distance. Architectural schemes that can attract people's attention and interest can enhance the quality of urban open spaces. Such building schemes can display visual content and contribute to the image of a district or a city. These qualities can be recognized in facades that serve as public displays and have been identified as media facades. The term encompasses a variety of luminous and kinetic facade systems. Media facades have the ability to attract people's attention and interest. They can stimulate reactions or interactions and improve the quality of urban spaces. They can be characterized by different types of control systems and involve moving images or components, depending on communication and environmental performance purposes of the designs. Media facades may be unsuitable for certain contexts, for instance in conservation areas, and can involve operational problems such as control, cost, and maintenance-related issues, as well as intensive energy use. The latter in particular does not facilitate the transition to zero energy or active buildings. In designing facades that can act as visual attractors, we need to consider buildings' energy balance more. This research looks particularly at how we can design facades that can attract visual attention and interest by minimizing operational energy use and offering opportunities for energy generation from renewable sources. Thus, this research aims to propose design strategies for architectural schemes that can act as visual attractors and supply buildings with energy generated through active solar technologies. It seeks to answer the following research question. How can facade designs stimulate visual engagement by facilitating the integration of active solar technologies to supply buildings with energy generated on site from a renewable source? Given its question, this research is exploratory and open-ended. It looks at possibilities for designing new active solar facades. In seeking to propose a set of design strategies, it develops interdisciplinary knowledge through qualitative research based on secondary sources, involving the review of literature and design cases. It draws from research on the psychology and neuroscience of visual perception, attention, and communication. It reviews key characteristics of media facades and solar technologies for facade integration, underpinned by the review of artworks and facade designs that present visually dynamic features and potential for embedding solar technologies. Visual engagement, or in other words, attracting people's attention and interest, is essential to architectural schemes' communicative function. It can be understood by considering the psychology and neuroscience of visual perception, exploring physiological and cognitive aspects, including attention, as well as studies on visual communication. It is found that displaying certain features through facades can attract people's gaze and attention. This is affected, however, by characteristics of the environment, as well as by the viewer's personal goals and other subjective influences. Architectural schemes may attract attention by displaying salient qualities of forms in the 2 or 3 dimensions, with colors, patterns, or figures. Motion in particular can be a very strong visual attractor. A sense of motion can be produced in visual designs even without any moving parts. For instance, through motion blur, with static 3-dimensional configurations which appear dynamic to moving viewers, or with particular illusory patterns. Visual engaging features emerging from the study of visual perception, attention, and communication can be recognized in media facades. These are characterized by a modular or pixel configuration. Media facades can improve the quality of public spaces. They encompass various luminous and kinetic systems and can be designed with diverse levels of visibility to stimulate different reactions or types of engagement. they may be characterized by different control systems and dynamic effects which may even result from the viewer's movement or from variations in the environment. Nonetheless, media facades present drawbacks in terms of suitability for certain contexts and operational problems including control, cost, and maintenance-related issues, as well as intensive energy use. Using energy to display dynamic visual content through the building envelope may not facilitate the transition to zero-energy and active buildings. On the other hand, there may be other ways of displaying dynamic visual content on facades which minimize operational energy use. This may be achieved with passive kinetics, or systems that do not involve electronic controls, but adapt, for instance, in response to changing weather conditions or by exploiting optics or material properties. However, such systems are less controllable, and moving parts can still lead to maintenance issues. Instead, static solutions producing motion impressions may be more durable and reliable. This also facilitates the integration of active solar technologies, and particularly of photovoltaics, the performance of which can be impacted by shadows from moving parts. Visual strategies for static facade designs that produce motion impressions can be identified by reviewing design cases of static artifacts that were designed to appear dynamic. This reveals design possibilities offered by three-dimensional facade configurations, reflective surfaces, layered transparencies, and illusory geometries such as moire patterns. It is found that digital technologies play an important role in the design of architectural skins that can produce motion impressions. These facade designs benefit from iterative testing from early design stages through computational modeling and visualization techniques. Reviewing solar technologies for building integration suggests options for integrating them into facade designs that display visually dynamic features. Among active solar technologies, including both photovoltaic and solar thermal systems, we find that photovoltaics in particular can be more suitable for integration into facade interfaces with pixel configurations for displaying dynamic visual content. Existing examples of media facades embedding photovoltaics use the energy generated from sunlight to power electronic systems with light-emitting or kinetic components of the facade display. This does not seem a very effective way of utilizing active solar technologies. They could be better employed to supply energy for internal building uses. As already mentioned, systems with moving parts may also require more maintenance than static facades. A review of recent developments in building integrated photovoltaic products, benefiting also from advances in thin-film photovoltaics, shows increasing opportunities for customization, particularly in terms of panel forms and colors, modular configuration, and patterns. Instead, there is potential for exploring the design of more visually dynamic solar facades. A review of developments in photovoltaic-based technologies shows a range of strategies for improving the efficiency of photovoltaics, which include utilizing high-efficiency solar cells, using bifacial or even three-dimensional photovoltaic modules, cooling photovoltaic cells, combining solar cells with compact, low-concentration optical devices, and using spectral conversion techniques to improve the conversion of light into electricity. These strategies introduce more possibilities for designing solar facades with qualities which can contribute to producing visually dynamic effects, for instance through reflective, refractive, diffractive, and textured components. These can be integrated into modular configurations, like those of media facades, to display dynamic effects through static interfaces in ways which emerged from the review of perception studies and art and design cases. Bringing all the findings together suggests design principles for stimulating visual engagement through active solar facades. Such principles are intended as passive strategies for producing a sense of motion through facades, which hints at new possibilities to be explored for integrating solar technologies into the building envelope. These design principles for solar facades include displaying digital content through a pixel configuration, conveying a sense of motion by producing motion blur, creating motion illusions, embedding dynamic reflections from the surrounding environment in the building skin, and exploiting the viewer's movement to display apparent changes in the facade. Thank you for your attention. Any questions and comments are welcome.